Emergency number 179-013.
Hello, my name is Ethan. My number is 97907.
Hello, my name is Caroline Perempuan Erwin. My matrix number is 178977.
Hello, my name is Wale Shakina binti Abdul Raza and my matrix number is 180661.
Hi, my name is Chong Chini. My matric number is 179106.
Okay, so now we're going to talk about the assignment that have been given to us by the lecturer. So guys, what do you think will happen if a ruminant consume more than 500 grams of ruminant? Darudi maybe?
I think ammonia toxicity will occur.
Okay. Kita?
Basically, what is a ruminant? Right? We don't know what is a ruminant. Anybody know what is a ruminant? Okay, so many different classes of ruminant animals are found around the world. Ruminants include cattle, sheep, goats, buffalo, deer, and other animals. These animals all have a digestive system that is unlikely different from our own. Instead of one compartment to the stomach, they have four. Of the four compartments, the rumen is the largest section and the main digestive center. The rumen is filled with billions of tiny microorganisms that are able to break down grass and other coarse vegetation that animals with one stomach, including humans, chickens, and pigs, cannot digest. Ruminant animals do not completely chew the grass or vegetation they eat. The partially chewed grass goes into the last rumen where it is stored and broken down into bones or swallowed once again, where it will pass into the next three compartments: the reticulum, the omasum, and the crude stomach. There is abomasum. Do you guys get what I mean?
So, meaning to sum it all up, a rumen has four compartments inside.
Yeah. Can I continue?
Yes.
Dairy calves have a four-part stomach when they are born. However, they function primarily as a monogastric simple stomach animal during the first part of their life. At birth, the first three compartments of a calf stomach, rumen, reticulum, and omasum, are inactive and develop. As the calf grows and begins to eat a variety of feed, its stomach compartment also begins to grow and change. The abomasum constitutes nearly 60% of the young calf stomach, decreasing to about 8% in the matured cow. The rumen comprises about 25% of the young calf stomach, increasing to 80% in the matured cow. Many of the plants that grow on earth cannot be used directly by humans as food. Over 50% of the energy in cereal crops that are grown for food is inedible to humans. Ruminants have the ability to convert these plants and residues into high-quality protein in the form of meat and milk. In addition, they feed on the rejects and cuttings from fruit and vegetable farming and the byproduct from food processing plants. Okay, I want to know about the urea. What is urea actually?
Okay, basically urea is a no protein nitrogen compound, or also known as NPN. Okay, fertilizer grade urea is added to cattle feed to boost the protein content. Urea is only a nutrient to ruminants that possess the urease enzyme, which allows the metabolism of the chemical. Urea supplies part of the protein equivalent in many of the commercial supplements formulated for beef cattle today. Urea is used to replace plant protein in the ration of beef cattle and sheep when the protein supplements are high in price. Most of the urea used in livestock feeds has 45% nitrogen, but some has 42%. Cattle, sheep, and other ruminants can use urea to replace part of the protein in their diet because of the host of microorganisms. Bacteria and protozoa in particular present in their rumen. More than half More than half of the protein consumed by cattle is broken down in the rumen into peptides, amino acids, and ammonia by the action of enzymes manufactured by the microorganisms. For cattle to use urea, microorganisms in the rumen must be able to convert the ammonia released from the urea into microbial protein. Urea is highly soluble in the rumen, and microorganisms rapidly decompose it to ammonia and carbon dioxide. The ammonia released from urea can go two pathways. Okay, it can be made into microbial protein, and it can also be and be absorbed through the rumen wall into the bloodstream, which can fit into the liver. The liver detoxifies ammonia by converting ammonia into the substitute for the urea. But for my explanation, you know what is urea by now.
So basically, we know that ammonia toxicity will occur. But what is the symptoms to actually know that that thing occurred? Intan, any idea? The basic symptoms, like very easy to see.
The clinical signs are usually apparent within approximately 20 to 30 minutes following consumption of protein or ammonia. So, you can see the symptoms include rapid bleeding, tremors, and slight incoordination followed by severe incoordination, excessive salivation, and rapid bleeding.
That's all. So now, Tina, any idea like how the chemical process of ammonia toxicity occurs?
For the chemical process for the urea, I want to continue what Zulaika just said just now. So then, some of the urea is recycled into the rumen. However, through saliva and by absorption from the blood through the rumen wall. However, if ammonia escapes the rumen too rapidly, the capacity of the liver is exceeded and ammonia spills into the main blood system. High levels of ammonia circulating in the blood can cause toxicity or even death. This suggests that if urea is to be an effective source of true protein for cattle, conditions in the rumen must be favorable for microorganisms to use the ammonia from urea before it escapes the rumen.
So actually, I would like to continue what Tina has also just said. So first of all, urea toxicity is also characterized by an overconsumption of urea according to their feeding. So the primary causes of it can actually be because of poor mixing of the feed, and then errors in ratio of formulation and inadequate of period adaptation. So in this situation, the breakdown of urea and the subsequent release of ammonia into the rumen, they actually exit the complex of the bacteria inside the stomach itself, and causes an increase of rumen pH value because ammonia is alkaline. So as it increases the pH value. So after that, this increases the alkalinity in the rumen contain wall, and this excessive amount of ammonia is absorbed into the bloodstream, and that's how the pH value increases. And then after that, the animal will have like what Intan had just said, dead saliva. That's one of the symptoms. And then after that, the concentration of ammonia
concentration, approximately of 2 to 4 milligrams, are generally associated with the urea-induced death, meaning that is what causes the death of the cattle. And then following by that, when the blood of the ammonia rises, it will interferes with the number of it will actually leads to interference with the physiological processes of the cattle, such as increasing the cellular energy metabolism in the cow itself. And by that, it actually affects the central nervous system of the cattle, and causes, and if it's prolonged long, if that things prolong, it will actually cause death. And you can actually notice that the ammonia toxicity is the actual problem of the death and not the urea. It's because the urea causes ammonia toxicity. So I think so that's what we will conclude today. Any further discussions? That's all? Okay, alright, that's all for us today.